Okay, this is the last installation of the Unit 4 test review. So we're going to go over a couple topics: domain, range, transformations. So first, let's do the graphing first, okay? It seems like these ones would be a lot easier, but getting a visual understanding of how the graph looks is actually, I think, quite a bit easier to work with. But I'll show you a shortcut for using if you have a graphing calculator, how to do all of these things afterwards. First, I'm going to show you how to do it by hand, though. So sketch the graph of each of these. Let's do the transformations first. So the transformations are always built like this. For the radical expressions, you'll have a number sometimes multiplying in front of your radical, and then sometimes inside the x value either be adding or subtracting some number under the radical, and at the very end it might be adding or subtracting some other number outside of the radical. So here's how it works out, okay? If you have some number that's multiplying out front, then that means that if it's negative, you have a reflection over the x-axis. And again, about the a value. If the a value, regardless of the sign, it doesn't matter what the sign is, if the number itself is between 0 and 1, then that means you also have a vertical compression. If that number, the a value, regardless of the sign, is bigger than 1, then you have something called a vertical stretch. And you just write VS on it for vertical stretch of that number. If you're adding or subtracting some number under the radical, then this is going to move the whole graph either to the left or to the right. If the h value is positive, it's moving it to the left. If it's negative, it's moving it to the right. And then if you're adding or subtracting some number outside of the radical, it's going to move the whole graph either up or down. And it's going to move the whole graph up if the value is positive. It's going to move the whole graph down if the value is negative. So let's use all that information for all these things, okay? So first off, we do have an a value. It's 2, right? So since it's 2, it's not negative, so it doesn't reflect, so we don't have to worry about that. It's not between 0 and 1, so we don't have to worry about that. But the number is bigger than 1, so that means that from this 2 right here, we know that we have a vertical stretch. The next thing that I see, the next transformation is this plus 1 right here. So since the plus 1 is in the radical, that means that it's this h value, and it'll either move the graph to the left or to the right. Since it's positive, it's moving to the left. So our other transformation is the whole graph moves to the left by 1. All right, now this one's kind of deceptive, and that's why you need to really pay attention to what I've been saying. We're adding 2 outside of the square root. So that means that we're going to be using which of these transformations right here, if it's adding outside the square root. Even though the 2 is in front of the square root, you might think that it's the a value, but it's not. It's the k value because it's adding outside the square root. So since it's adding outside of there, it's either going to move up or down, and since 2 is positive, it's going to be moving up by 2. Then we have a plus 6 that is adding inside the square root, so that's the h value, and since it's positive, it's moving to the left, and since it's 6, it's left 6. So those are all the transformations that you're going to be using for this. All right, now let's move on to graphing the thing out, okay? So graphing it, it's really easy to graph stuff out. Here's how we do it. So when you're taking, since we're doing a square root, we want to take numbers that we can, find the square root of real easily. So just a reminder, these are numbers that we can take the square root of real easily because the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. But if we took the square root of some random number like 5 or 2 or 3 or something like that, we couldn't find an even square root. So we don't want those numbers to be inside of the square root that we have. And let me rewrite this because that pen, kind of might confuse us as to what we're doing here. All right, there we go. All right, so here's what I like to show my class how to do. So we kind of build a modified t-chart where it's got 3 columns instead of 2. The middle column is your x value, the y column's on the right. And then the numbers that we're going to put here are the first couple square root numbers that we know. So we can take the square root of 0, we can take the square root of 1, we can take the square root of 4, we can take the square root of 9, we can take the square root of 16. So that's what we want to do, take the square root of those numbers. So that's what we're going to want to ultimately have inside of here. The difference is this. We actually have this equation inside of the radical. So we want to take the equation, x plus 1, and set it equal to each of these square root numbers. So set it equal to 0 and solve for x. So if we want to solve for x, we subtract 1 from both sides, so we get x equals -1. All right, so just this one little change, watch what happens, okay? So we plug in -1. -1 plus 1 is 0. And this just becomes the square root of 0. So 2 times the square root of 0. And the square root of 0 is 0. 2 times 0 is 0. So my y value is 0. That gives me a coordinate that I can work with. -1, 0, right there. All right, now let's figure out how to get 1 inside the square root. So we take the equation, x plus 1, and we set it equal to 1, because that's what we're trying to get, 1. So to do that, we subtract 1 from both sides, and we get x is equal to 0. So that's the other x value that we're going to plug in, 0. So we plug in 0. 0 plus 1 is 1, so this becomes the square root of 1. And the square root of 1 is 1. 1 times 2 is 2. So that gives us another coordinate, 0, 2. So go over 0, up 2. That's our next coordinate. Now I want to get to 4, so I take x plus 1, and I set it equal to 4 and solve. So if I subtract 1 from both sides, I get x is equal to 3. So now I'm going to plug in 3. 3 plus 1 is 4, so this becomes the square root of 4. The square root of 4 is 2. 2 times 2 is 4. So that means it gives me another coordinate, 3, 4. So go over 3, up 4. There's our next coordinate. Let's find out how to get to 9. So x plus 1 is equal to 9. So if I subtract 1 from both sides, x equals 8. So 8 is going to be the next number. And it looks like that's the end of my x value. So I'm not going to have to do this one. But let's go ahead and plug in 8. 8 plus 1 is 9. So this becomes the square root of 9. Square root of 9 is 3. And 3 times 2 is 6. So that gives us our last coordinate, 8, 6. All right, so this is how our square root function goes. It starts at that initial point that we started with at 0. And then it just keeps going. So there's our square root function. And that's how you can graph it out. Let's do the graph of 26 really quickly, and then I'll show you how to find the domain and range. Those are super easy as well. Okay, so here we go. We do the modified t-chart. I'm going to skip a couple steps, so you can if you need to remember what some of these steps are, you can just kind of go back and look at that previous example. But let's find the x values first. So how do I get 0 from x plus 6? So x plus 6 is equal to 0, so x is equal to -6. X plus 6 is equal to 1, so x is equal to, if I subtract 5 from both sides, -5, or 6 from both sides, -5. If x plus 6 is equal to 4, if I subtract 6 from both sides, x equals -2. To get 9 from x plus 6, I subtract 6 from both sides, and I get x equals 3. And then to get 16, I don't think that'll fit, but let's see, subtract 6, yeah, x equals 10. That's not going to fit on this graph, so I don't have to worry about that one. Now I plug in the numbers. So if I plug in -6 to the equation, all right, let me rewrite this. Y equals 2 plus square root of x plus 6. Okay, so -6 plus 6 is 0, square root of 0 is 0. 0 plus 2 is 2, so that gives me one coordinate, -6, 2. So left 6, up 2. Plug in -5. -5 plus 6 is 1, square root of 1 is 1. 1 plus 2 is 3, so -5, 3. -2. -2 plus 6 is 4, square root of 4 is 2. 2 plus 2 is 4, so -2, 4. And then 3. 3 plus 6 is 9, square root of 9 is 3. 3 plus 2 is 5. So over 3, and then up 5. All right, so here's how our function looks. It goes through there, goes through there, goes through there, and then it just keeps going. So there's our square root function. Pretty interesting, right? So these aren't, super crazy difficult to graph. Just make sure that you practice with them enough, and you'll be okay. All right, now for the people that have the graphing calculators, obviously, you can just type the expressions in. So y equals, and then 2. So 2 square root of, and then x plus 1. And then, graph it. So zoom 6. There it is. And then, if you need some coordinates, go to your table and then just plug in the points that actually make sense, like -1, 0. Those might sound familiar. -1, 0, 0, 2, 3, 4, 8, 6. See, it's finding the same stuff. So, if you want, you can use your calculator on it entirely. All right, the last part is just the domain and the range. Here's what makes it really easy for you, okay? You know that first coordinate that we had to find? -6, 2, and -1, 0 for both of these graphs? That gives you the domain and the range. So the domain, remember, is your x values, so I'll write it over here. So the domain is your x values. all right? And the first x value is -1. So here's all you have to remember. From the graph right here, are all the x values on the rest of the graph going to be to the right of the -1 or to the left of the -1? If it's to the right, then they're greater. So all the x values are greater than or equal to -1. That's your domain. Now for the range, the y value. So the y value is 0. So for y values, they go up and down. So is the whole graph up above 0 or down below 0? Well, they're all up above. So that means that the y values are all above 0. So greater than or equal to 0. There's domain and range. This is about as easy as it gets when you're graphing out. I think the only thing easier than this would be like linear equations. All right, now for the domain and range for this graph. All right, the domain is the x value, which is going to be -6. See, -6. And then the graph is all to the right, so it's going to be greater than or equal to -6. So there's our domain. X is greater than or equal to -6. Now let's try the y value. That's at 2. So for the range, y and 2. And then it's all above 2, so it's going to be greater than or equal to 2. There you go. Domain and range on your graph. When you don't have a graph, you can still do the same kind of thing. You just kind of need to remember if like the graph is going up or down, or to the left or to the right. Here's how you can figure that out. If you have a negative number in front of your radical, it's going to be pointing downwards. Okay, so there's no negative numbers pointing downwards, so that means that our y values are always going to be greater than or equal to something. All right, now for the domain. The domain, the x values are always going to be greater than if the x value is positive. If it's negative, then it's going to be less than. So you just write greater than for both of those. Now watch this. This is the part that's pretty cool too. If I go back on these numbers over here, the domain numbers, it should look familiar. They're the same numbers that are up here. The number that you get that's adding or subtracting is always going to be the number on your range. The opposite of the number that you're adding or subtracting in there is going to be on your domain. So like for this one, the number that I'm adding or subtracting is -1, so the opposite of that is 1. So it's, x is greater than or equal to 1. The y value, the number I'm adding outside here is nothing, so 0. And there's my range and domain. For this one, the opposite of the number inside is 2, so x is greater than 2. And the number on the outside is -3, so y is greater than -3. That's the domain and the range. Okay, so that's it for the test review. If you need some additional help, just don't be afraid to reach out to your teacher and get it. All right, good luck on your tests.